In this video, I'm going to review solving linear and absolute value inequalities. Alright, so this is an example of a linear inequality. Now, it doesn't matter which side you have the variable on, but it's always easier if you have it on the left side. So what I'm going to do is I'm going to flip these two sides around and rewrite it as 7 times the quantity negative 2n minus 5 is less than or equal to negative 105. All right, just make sure you turn everything around, and then you'll be okay. So let's go ahead and distribute this 7. 7 times negative 2n is negative 14n. 7 times negative 5 is negative 35, less than or equal to negative 105. All right, you want to combine your like terms now. So I'm going to add 35 to both sides. So that gives me negative 14n is less than or equal to negative 70. And now I'll divide both sides by negative 14. All right, and dividing an inequality by a negative forces you to flip the symbol. So less than or equal to becomes greater than or equal to. A negative divided by a negative is a positive, so positive 70 over 14, which reduces to 10 over 2, which reduces to 5. Goodness. So n must be greater than or equal to 5. So if we graph that, we'll go to 5 on the number line. It'll get a closed circle or a solid circle because it's equal to. So that means it should be included in the solution set. And if the numbers that are also solutions are greater than 5, that means we shade to the right, to the greater numbers. So the solutions include everything from 5 inclusive all the way to infinity. Okay, let's do the next one. All right, this is an example of an absolute value inequality. So you're going to have to write 2 inequalities for this one, excuse me. Before you begin absolute value inequalities, you have to realize you must isolate the absolute value expression. So since it's being multiplied by 7, I'm going to divide 7 away, and 21 divided by 7 is 3. Now it's isolated. So you're going to write 2 inequalities from here. The first one will be the same but no bars. The second one is the same but left side negative. And when I say that, I mean put the leftward expression in parentheses with a negative on the outside. But everything else should be the same. Alright, so let's solve these two. Alright, and this one I would add 2 to both sides, so n must be greater than 5. Over here, I'm not going to distribute the negative because that would cause my n to become negative. So I'm going to divide it away. And if you divide an inequality by a negative, you must flip the symbol, and 3 becomes negative 3. Now simply add 2 to both sides, and n must be less than negative 1. So let's plot these right here. If n must be greater than 5, let's go to 5. We're going to use an open circle this time because it's not equal to. And n must be greater than means you shade to the greater numbers, which is to the right. And for n is less than or equal to negative 1, go to negative 1. Again, an open circle for the same reason. And if n must be less than, you'll shade to the lesser numbers, which go to the left. So we have 2 solution sets. So let's write them in inequality notation. So for this first one, it stretches from negative infinity to negative 1 exclusive. We skip over no man's land by writing a union symbol. It picks back up at 5 exclusive and goes all the way to infinity. So there's the solution set in interval notation and the graph. All right, look at this one. Absolute value of 10n is less than 70. The absolute value expression is already isolated, so I can write my two inequalities. The first one is the same, but no bars. The second one is the same, but left side negative. And again, put the left side in parentheses with a negative on the outside. And if we solve for n, we get n is less than 7. And over here, if we divide that negative away, we get 10n is greater than negative 70. And divide by 10, and we get n is greater than negative 7. All right. So, this is going to be what's called a conjunction. They're going to meet in the middle. So, for this one, n is less than 7. Let's go to 7 on the number line. We use an open circle because it's not inclusive. And the numbers must be less than 7, so we start shading that way. All right, and then over here, it says n must be greater than negative 7. So here's negative 7 right here on the other side. Greater than goes to the right. So these are going to meet in the middle. And that represents the solution set. And in interval notation, we would say it goes from negative 7 exclusive to 7 exclusive. All right, let's take a look at this special case. All right, we've got n's on both sides, so let's distribute to start cleaning it up. 6n minus 6 equals negative 6 plus 6n. All right, I'm going to combine my like terms, so I'm going to subtract 6n from both sides, but look what happens. All of my variables cancel out. Now, when that happens, you have one of two answers, either all real numbers or no solution. And you determine it based on whether this statement you're left with is true or false. So is negative 6 greater than negative 6? No, it's not. They're equal, so that's false. So that means there's no solution to this one, and your graph will just remain blank because nothing should be highlighted. Nothing will make this true. All right. One more. It's absolute value. Absolute value expressions must be isolated first, so I'm going to divide by negative 3. And I'm left with the absolute value of n minus 1 is greater than, just greater than negative 10. So it's isolated. Here's where we would write two inequalities. The first one the same, but no bars. The second one the same, but left side negative. Alrighty, so to solve, I'm going to add 1 to both sides, and I get n is greater than negative 9. And then over here, I'm not going to distribute because that would make my n become negative. I'm going to divide it away instead and flip the symbol and make the other side the opposite. And then I'm going to add 1 to complete it. Okay, so this says n must be less than 11. Okay, it's not on the graph. That must mean something. So there's 11 with an open circle. And then n must be greater than negative 9. Well, there's negative 9. The open circle must be greater than. Are they really going to meet in the middle? Something doesn't seem right. If you ever have doubts, you should pick a point that's in your solution set and check it. Let's try 0. If I plug in 0 into the original problem, like this, let's evaluate. Well, 0 minus 1 is negative 1. The absolute value of negative 1 is 1. Is negative 3, negative 3 times 1 is negative 3. Is negative 3 less than 30? Yes. So that's a true statement. So this is going to cover every single number. So the answer for this one is all real numbers. They all work. And there was actually a way for us to tell from the very beginning. Once we isolated the expression right here, Absolute value must be non-negative, meaning the answer must be positive or 0. And all positive numbers and 0 are greater than -10. So from right there, we could tell that any number would make this true. Therefore, all real numbers.